You may know the Packet Pushers as the greatest networking podcast in the world, or as the first outsiders to get software-defined networking. Blowhards, speakers of truth, builders of networks, haters, lovers, all of these things may or may not be true depending upon who you ask. In 2013, the Packet Pushers got all up in your data center with software-defined networking. In 2015, cocked and locked on software-defined WAN. In 2016, they are on stage in Vegas for once only live appearance at FutureNet. Please welcome Greg Farro and Ethan Banks from the Packet Pushers podcast with special guests Bruce Davie and Simon Crosby.
Oh, thank you very much for that. How are we all this morning? How many people have got a hangover? I'd like to give a special shout out to Bruce. He's telling me that he's got a double hangover this morning. So in honor of that, I've decided to start a Kickstarter, kickstarter.com/Bruce Davies Hangover Cure. So if you'd all like to contribute, maybe we can get something working out about that. Keep things going.
So I've got to say, I'm actually so badly hungover that I'm actually not upset about the fact that my name's not on the slide.
Well, that Greg's name is misspelled.
Yes. Well, you can call me anything you like, just don't call me late for dinner. So today what we're doing is we're going to be running a session talking about the tension between security and networking and whether security in particular should be in the endpoint or in the network. So let me just read some prepared notes here. The relationship between networking and security has been very close for the last 20 years, and in most cases it simply hasn't been possible to secure applications in the network. You know, we've been dealing with software from Oracle and Microsoft, and those things have been, well, less than excellent at security over the years. And so we've used the network to rectify these issues. So firewalls, IPS servers, applications and proxy engines to inspect, analyze and block network flows. But times have changed. Once there was many protocols, we've got this massive convergence. We've got SSH, HTTP and DNS, and really our once thriving ecosystem of IP protocols is pretty much dead. Now we are starting to move to things like network microsegmentation as the future of network security, and today you can deploy microsegmentation in your data center and in your SD-WAN, and we're seeing early signs of this coming into the campus. So our guests are here to discuss this today: Bruce Davie, Simon Crosby and Ethan Banks. So let's start off with a networking discussion around middle boxes. Now many of you know that we put these boxes in the internet. The original IP protocol was designed to be an end-to-end, that is client to server, point-to-point connection between the two over a multi-point network. But for the last 20 years, we've been blocking the network with middle boxes, firewalls, IPSs, proxy servers, and all of these types of interdiction are starting to cause massive, massive problem. So the question I wanted to throw out to Bruce, just to kick things off, is middle boxes are everywhere, but are they the future?
Well, I mean, I certainly hope not. So, I mean, I think, can I just actually spin that question a little bit? I mean, the question is, why do we have them at all, given, you know, the sort of the history? And I think if you look at sort of the way the sort of IETF purist types, you know, sort of the true end-to-end folks look at middle boxes, you know, for many, many years they just said, it's just a terrible idea, they shouldn't exist. Yep. And, you know, there's probably another thread we could have there about sort of the extent to which the IETF sort of puts its head in the sand about things that they don't like and says they shouldn't exist, and meanwhile the things do exist, but the IETF does nothing about them. So I think there was this idea that, like, you shouldn't do middle boxes. Like, if you want security, you should just be, you know, IPsec everywhere, you know, encrypt everything end to end, and, you know, God handed down the end-to-end principle, you know, via Clark, Salter, and Reed, and so, you know, we all live by that religion, and therefore thou shalt not have middle boxes. And so, you know, I think the question of, like, well, how did we get there? It was basically because, to some extent, the original internet architecture pretty much neglected security. And I think, you know, you'd find guys like Dave Clark would admit, yep, you know, all things considered, that wasn't that high on our list of things that we were thinking about.
Yeah, working first, security second. Mm-hmm. It's got to work first, and then
exactly.
And then you've got a security problem.
And the idea was, like, you know, the whole idea was, let's interconnect everything. Well, you know, so let's not be thinking about how to stop packets getting through. Let's think about how we actually get them through.
Well, I mean, Jeff, I think the point about middle boxes is that ultimately the damage it causes to the internet. So when you put a firewall in the path, we now block ICMP PM touch, right? So if you're trying to do echo replies to find out if a packet's being fragmented, firewalls block that. Now all of a sudden you've got this problem where the internet bandwidth is increased. You know, we've regularly got gigabit or multi-gigabit connectivity, and you want to start using jumbo frames. You want to get beyond the 1500 byte frame, but we can't because middle boxes interdiction prevents that from happening.
Yeah, I mean, and this is sort of why, you know, there's a sort of an element of correctness in the why you say metal boxes are a bad idea, because they make all kinds of things break. But the reason that they are there is in part because you needed to have something you could go and point to instantiate security policy. Like you couldn't say, oh, I'm going to make sure every OS in my enterprise is correctly up to date and completely bulletproof, and I'm then going to encrypt all the traffic between those things, going to handle the key distribution. There's just so many things that were completely intractable. The one thing that was tractable was to say, well, all the packets come in and out of my enterprise through this one point. So if I put a middle box there, I know all the packets are going through it, and that's a thing that I can go and control. And I mean, I think this is actually one of the things where sort of traditional networking people really missed the boat, was this idea that the IT community cares more about what can I actually control than about correct architecture. And so,
networking has, as a professional network engineer for FTSE 250 companies for the last 20 years, I spent 80% of my time doing security, not actually connectivity. Like connectivity was a given. You plug a cable in, server connects to switch, blah, and that was the end of it. And the firewall was the last line of defense, first and last line of defense. But
Bruce, I wanted to add, you make it sound like we had a lot of architectural options and we just said, no, we like the firewall thing. That's a good thing to do because it's that central point where we can instantiate policy. But what were the other options if we're looking back in time here?
Yeah, well, I mean, I think the other options would be to treat security more as an end-to-end problem. And I think that was the challenge, was that end-to-end solutions were completely unmanageable and basically didn't meet the needs of the people who were actually given the job of making their networks secure.
But now we've got encryption, right? So now all of a sudden payloads are being encrypted end to end. We're talking about desktops, all like things like what was HTTP is now HTTPS, and invulnerable.
Wait up. Okay, so first of all, every single, and this is Simon, by the way, every single enterprise breaks TLS at the proxy. Okay, and then they may reuse it inside or not. In general, they don't. Okay.
Yes.
And so the end-to-end thing breaks at the enterprise boundary anyway, right? So let's just be very clear on that. And so the proxy is another place where they impose policy. But the end-to-end idea of security is completely meaningless, okay? Because the attacker, and I think you have to talk about your attack surface and what you're vulnerable to. The attacker targets a vulnerable application on an endpoint, encrypts their payload. Fine, maybe you deliver it all the way there encrypted, good for you. And then it breaks out into the operating system, which has got rights to go anywhere on the enterprise network.
Yeah,
at which point we're done. Okay. So the network cannot solve the security problem.
We can't solve the exfiltration problem anymore.
Well, let's be clear. Exfil, I think, is the last generation of attacks. Let's just be very clear. The attacker, if you just take crypto malware as an example, the attacker has figured out how to nail you at machine speed now. They don't have to go through this hard problem of figuring out where your valuable data is and slowly getting it out through DNS or source-rooted IP or whatever. They just encrypt all your stuff and then make you pay. And they probably won't even give back, okay? So the attacker is already moving to machine times kill attacks. So ultimately, there is, the network middle boxes have been an abject failure, okay? So let's be very clear. There was a while in the last couple of years where Google was feeding malware to people in ads. These are trusted websites, okay? So it's not simply a matter of carving off the part of the internet which is scary.
And making it safe by putting a barrier around it.
You can't do that.
That's like locking the windows and pretending your daughters are safe.
Yeah,
They can't
and
get out.
Google's done the right thing. They've said Cheerio Flash and a whole bunch of other things. But nonetheless, the problem from an attacker's perspective is take hold of the enterprise endpoint. 90% of breaches start there, and that's 100 million lines of code.
So Simon, are you arguing that middle boxes have no role?
In the future, it will be a world composed of clouds and users. Okay? And the user will be sitting in Starbucks and accessing the cloud. And your network will be totally irrelevant, other than from perhaps a compliance requirement perspective. So Google absolutely nailed it when they said that certain classes of Chromebooks, for example, can access Google internal apps from Starbucks because they actually trust them. Okay, so let's get real. The idea that the enterprise can defend a boundary is nothing more than sheer stupid repetition of, oh gosh, Troy.
Yeah. Well, I think there's a few other things in here. Let's also point to our carriers who are using their networks to capture data. So there's a big privacy problem in carrier backbones where they're looking at the data that goes across, especially when it's unencrypted. And Verizon has a $24 billion revenue stream out of selling data about what traffic's crossing their backbone.
Yo, I think
ad tech.
Google's revenue stream is bigger.
Yeah, but they're not. But they don't own the telco backbones, right? The reason that Verizon bought AOL and HuffPo and all those media properties is because they can use the network to get better targeting if they know what the endpoint and the network is, right?
Yeah.
And then they can actually make more money out of it than you can otherwise. So there is a privacy issue. Like what you're saying in the enterprise is true, but there's also the carriers. And we now have the IETF looking seriously, Google's promoting it, but doing TLS over UDP.
Yes.
And the reason it works 25% faster is because there's no middle boxes. UDP flows don't go through the firewalls, they don't go through proxy
enterprises will
servers.
just block them. But wait until IoT happens, and IoT devices, my goodness, you really want that stuff to be encrypted, right? And then the enterprise is going to have this huge problem, which is, I really would like to block UDP, because they all do, but now it's coming at me and I don't know what it is. And I can't look at it before it hits some endpoint.
Yes.
And then have the same security problem, which is it's going to hit an endpoint, and at that point I'm vulnerable.
Right. So the way that we sort of overcome this issue of firewalls, so the general consensus is that firewalls is degrading in value, or any form of middle boxes, the value of proxy servers, the value of IDS systems, driven largely by encryption, but also by volume and a range of other issues. Performance is a big one, increasingly, especially in carrier backbones. Remember, there's two networks in this world, enterprises and carriers, right? You've alluded to endpoint security, and we'll talk more about that in a bit, but we have microsegmentation rising. Now, in the enterprise, we have two types. We have data center microsegmentation using software overlays, and we also have software-defined WAN. So we have the software-defined WAN vendors are effectively bringing microsegmentation to your WAN sites, often based on applications, not just on dumbass IP addressing and subnets and stuff like that. So more importantly, we're seeing a rise of microsegmentation accessing metadata. So that is, we're now doing networking based on metadata in the servers. What's the app in the servers? What's the name of the server? Who configured the server? Some sort of administration maybe in vSphere or vRealize or OpenStack to drive that. So the question is, what is the limits of microsegmentation as a security tool? We know that it works. We know that we're adopting it. We're spending a lot of money on it. dig. And are there limits to it?
Sorry, do you have an opinion about the value of microsegmentation?
I have an opinion about the price of microsegmentation.
You obviously haven't done a good job negotiating. But, I think the value of microsegmentation is actually, I think it's very clear, and we can argue about whether it's whether the price matches the value. But the thing is that it is taking a much more sort of principled approach to how you actually isolate different parts of the network from each other. In the sense that, the reason you put a firewall at the perimeter was because you could see the perimeter, and as Simon eloquently said, that's well known, in the time of Troy as a not very effective approach, just guarding sort of the one entry point. And so, the more I talk to customers, the more they recognize that the perimeter is a dead concept. You cannot any longer define the perimeter of your network.
I mean, just smartphones. As soon as you connect them to your network,
It's not even that. You just connect your device to the Wi-Fi network in this hotel and hit the captive portal. It's fine here, maybe. But just try it in China or some other place where you're not so happy, right? So in general, there is this big assumption of trust in many of these protocols, and this is an application. My browser says, hey, here, I've hit a captive portal, but at that point I'm owned, okay? And so in general, the idea that you could force your endpoint, in my case, an end user endpoint, to be on a VPN, forget it. You're not even on the internet yet, but I've got you.
Yeah.
Okay, and it's all about the endpoints, because endpoints and data stores. Endpoints are servers too. So ultimately, what is microsegmentation? It's a way to reduce the attack surface.
Yeah.
And reducing the attack surface is good, right?
Microsegmentation, though, we've moved the perimeter closer. It's still not endpoint security, though. Yeah.
Well, I think it depends on exactly what definition of microsegmentation we want to take. Because I think having a discussion with somebody the other day about sort of the Humpty Dumpty nature of microsegmentation. Words mean whatever I want them to mean. And so if I have some sort of substandard feature in my...
Is that like software defined, which is...
Yeah, exactly. But so, I think a sort of reasonably good working definition is that you are able to define a set of of policies about what entities can communicate with each other. And in the product that I'm involved with, we sort of think about those entities roughly corresponding to VMs, but that's an artifact of the world that I happen to live in.
Yep.
And in the sort of very near future, we'll be thinking about that more in terms of the containers being the endpoints that we can name.
Yes,
and I think in
there's a
in
spectrum.
Simon's world, there's a much
Microsegmentation has been a spectrum for 30 years. It started with VLANs, and then it was MPLS, then it was virtual instances, then it was.
Well, and this is actually where I sort of have a bit of a gripe about the overuse of the term, which is I think segmentation is what VLANs give you, and microsegmentation is when you start to get down to a significantly finer granularity than has been possible until a couple of years ago. And so, I think whether that level of granularity is, per VNIC, which is, actually it's fine, but it's not super fine, or whether it's an individual app running on a mobile phone.
Well, no, just think about it. Just go data center for a sec. One app per VM, because that's how people use this stuff, right? And then you own its storage and you own its network. Goodness me, that's about the only place you have a shot of seeing if it tries to get owned, right?
Yep.
So arbitrarily granular on segmentation on the basis of an app or a right to use is the way to go. And so this is an incredibly powerful abstraction for both data center and end user endpoints, right?
I think the other thing, maybe the thing that we didn't talk about in microsegmentation is once I've carved a section out, segmented that and reduced the attack surface, is I can now apply different security policies per segment. I might have a low security posture on this segment, but I might have a very high security posture on this segment. So maybe today we have like a one-size-fits-all security policy. Everything goes through a proxy server, everything comes through application inspection / firewall / waste of time and money. Sorry, did I say that out loud?
Yeah, you did. Hundreds of millions of dollars of abject failure. I think
and single points of failure. HA, pseudo high availability.
I feel like we should start a rock band called Abject Failure.
I think I did in high school. I mean, but I think the thing about microsegmentation that people forget is it actually makes operational security possible for the first time in a long time. You don't have to have a one-size-fits-all security policy. I can have a microsegment in a data center, in a campus, in a WAN, and apply a set of security policies. So if this is my PCI, then I've got the anal retentive policy, inspection engines up the wazoo, private key and crypto, blah, blah, blah. But over here is a person's internet access, and it's just isolated and passes out to the internet. And maybe I'm pretending that my endpoint security is doing something.
Yeah.
The challenge there is so somebody accesses the internet, and I still manage to compromise the endpoint, it's easy to pivot and go on the other networks. Yep. And so ultimately, this intimately engages other forms of isolation on the endpoint. So in the data center side, one app per VM. If I take the VM, fine, just restart it, okay? Mm-hmm. And then we reattach it to its other abstractions, right? So the key value here is that, people don't own things by owning the network. They own the app. And then they use that operating system environment to spin around and go on a different network segment or go somewhere else deeper in the enterprise. And so microsegmentation inherently limits the attack surface by reducing access from that VM, right? So that's the principal value proposition. It's this ability to control risk through better design.
So the point I wanted to add to that too is you started to touch on the sort of the operational capabilities that we're getting now. And that to me is the super important thing. So, one reason we had firewalls is because you could point to the thing and you could configure it and you could create the illusion that you had some security. And to me, it's a lot like the guy who's searching for his lost keys under the lamppost, not because that's where he dropped them, but that's because where the light is. and so there's the same idea. It's like, well, yeah, perimeter security is useless, but at least I know where the perimeter is, so I'm going to put some security there. But so to go and say I'm going to put security policies in place and have them distributed so that they're enforced at every single application or every single VM or whatever the granularity is. A few years ago that was operationally infeasible. And I was explaining to a famous computer scientist about distributed firewalling, and she said, well, it seems like we could have done that 10 years ago. It's like the one thing we didn't have 10 years ago was the ability to operationalize that.
No, I think that's right.
And that's effectively what sort of the SDN controller brought us.
So we're at the VMworld conference, and this FutureNet event is in the middle of that. I was having drinks with somebody the other night, and I had the Cisco CCIE on the right-hand side and the VMware VCDX on the left-hand side. And they said, we're
Sounds like
tossing up.
Sounds like an awful experience.
Actually, they were both pretty civil to each other, all things considered. There was no blood.
Yeah.
And the networking person was saying, we should really have firewalls. We need firewalls on the top. And the VMware said, what's your view? And I said, look, the mistake that most network engineers make in terms of taking on security is that they put one firewall at the top of the data center. And then they say, well, and then it becomes mission critical because it's the only firewall. And so they make a HA pair. Well, there's a fundamental problem right there, right?
Right.
And I said, well, so if you're going to do microsegmentation, using something like a tool like NSX or any of the other SDN products, whatever, then think about having virtual firewalls. Instead of having one physical, have 25 virtual firewalls, one for each segment. And then you can start to apply policies. And he goes, oh, but then I've got 25 firewalls. I say, yeah, but you've got 25 firewalls with 25 rules each, instead of one firewall with 5,000 rules that when you deploy it, fingers crossed, hope you.
But and one central point to configure those 25 firewalls.
We usually build an SDN, a software-defined firewall infrastructure.
I think it's really important to understand what the attacker is trying to do. So every single attack that I see nowadays can walk through any network protection. Okay, so here's some interesting stats for you guys. And networking people don't necessarily get
It has to be said, the only time you see those attacks is after they've walked through the firewalls.
Well, so look,
the
99% of malware morphs into a new undetectable form in less than a minute. Every single time it runs, it does the polymorphic thing. Okay, so good luck trying to detect it. Forget it, right? The app guys, so all the CryptoLocker guys and so on, they go to sleep. So you can throw them into a sandbox or do whatever the heck you like. They even demand user input to click on a thing before they attack. Okay, so you ought to expect that the attacker will become increasingly sophisticated as we become sophisticated, because that's what they do. Okay, and ultimately it is an app issue.
Yep.
Okay, and so we have to take on this.
The thing is that you say, remember yesterday we were watching Thomson Reuters was presenting, and he was saying the point is that a lot of our developers use continuous integration and continuous deployment and DevOps as an excuse to just keep implementing the same old stuff, like to just pretend there's no security problems, right? And I think the reality is that we all know, everybody knows, that yes, security has to belong in the app, but the reality is that security isn't being implemented in the app. I mean, not even our highly vaunted, very expensive, overpriced software vendors are doing it right.
So I don't think anybody here is arguing that the security is going to get implemented in the app. You weren't saying that, were you?
But if you're not implementing security in the app, it has to be somewhere else. Right?
Agreed.
So there's still a role for...
But it has to be, so the question is how granularly could you isolate within a runtime? And the answer is you can do it on a per task basis, that is, on a Windows endpoint, say per process, right?
Yeah.
So every single tab and browser is a different VM in my world, right?
Yep.
And that means I don't ever have to patch. The thing just puts everything in a VM. Every document I open just goes in a VM.
But you're just reducing the attack service to one VM, a micro-hypervisor in an operator.
That's the whole point, right?
And each one of those is attached to its own virtual network.
Right.
So
what about microsegmentation in MDM, so mobile device management?
Yes.
You've got all of these tools. They're extremely pricey, judging from the amount of marketing I get from these organizations. I can tell how much a price costs by how much marketing is going on, general rule of thumb. And I mean, are they doing the same sort of thing? Are they micro-hypervising? Are they micro-OSing? Or are they just doing basic dumb access control?
ultimately, it's a more granular expression of what access rights a user or some component of the infrastructure has to some other component of the infrastructure, right? So just to be very clear here, you might be using Box, so SaaS, in which case, good luck trying to find an NSX to manage it, okay? But there is an API there which gives you extraordinarily granular access to what every user is doing on a block-by-block basis on every single file around the planet on a second-by-second granularity.
Right.
Great. That gives me exactly what I need in the sense of setting policy, because I can also control it. So the concept of...
By the way, I'm just going to send a note to product management right now.
The idea, the basic idea is that you reduce access based on permissions and make it as granular as possible, perhaps on the basis of user groups or even individual users to particular components of the infrastructure or applications.
So this raises a point of metadata. So a lot of the times with microsegmentation, we always get into a debate about metadata. How do I segment? What are the parameters around how I do the segmentation? How small do I make it? How big? So the classic example today is in the hypervisors. If my server name has these first 4 characters, that's one microsegment. If it, or maybe I have other rules and policies. So now I'm using metadata to set security policies. So the question is, there's a couple of things around this is extracting metadata increases the complexity by order of magnitudes. And back to what Nick McEwen was saying yesterday about abstractions allow us to scale the internet, but every abstraction also piles on the complexity and the opportunities to muck things up, as is clearly proven by just about everything. If we start extracting more and more metadata and getting more and more metadata from sources, polling APIs, polling, as you say with Box, all of a sudden we've got new attack surfaces, so stealing your metadata, stealing your access control policies via API endpoints, and then I've got repositories of metadata. So once I fetch that data, it then becomes an attack point, a key attack point, a single point of failure. And the question is that generally the security people that I've worked with are not very good.
Correct.
Generally they're people that, the ones that are so-called really good generally still have long hair, talk about their judo and their lockpicking skills, and not so much around their IT capabilities, right? Or they waffle on about security policy in the era and blah, blah, blah. So I'm not sure that IT security, especially enterprise security, is ready to handle metadata. What are your thoughts?
Oh, I would agree with you. Look, if you look at the rate at which you're collecting, first of all, abject failure back is that the bad guy's still getting in spite of all the boxes. And so there is this horrible statement that even the analysts would make, which is that you've probably been breached already, which is totally sucky. So then everybody says, fine, go monitor everything. Let's collect all this metadata and then try and figure out later, which basically means you're collecting a Splunk-like amount of data, but just try and do that across 200,000
now it's a machine learning opportunity.
endpoints.
Yay, more money.
Right. By the way, machine learning, it's kind of helpful post-breach, but it's not good for detection because Turing still applies, right? So ultimately, you end up with a security team owning a monster SAN and still not knowing what to go and look for. Okay. And it's tragic. Look, let's be very clear. The security pros are not equipped in the organization. They're not, they don't have the clout to go and do a whole lot. They're generally advisors of security. And much as they'd like to help, they get forced into this role, which is essentially the sweet strippers of the cyber world, right?
Yep.
Go and look through the false alerts and try and figure out if they're real.
I always made sure it was their fault. Bruce, what's your thoughts?
What they do then is, all they do is they send Freddie out to the cubicle farm and he reinstalls Windows.
Yeah.
So I kind of want to make a plug for the work that my colleague Tom Korn has been doing, which kind of hit the light of day 18 months ago as sort of the Goldilocks concept. And I think you can go search for various videos of this. But the core idea of Goldilocks was that sitting inside a hypervisor, you've got the sort of the happy medium between not too hot, not too cold, hence the Goldilocks thing, in the sense of you're close enough to the application to look in and see what's going on. So that's what you would call metadata. We call it contextual information. You can see what OS is running, what processors are running. You can see a lot of things about what's going on from sitting in the hypervisor. And then, because you're in the hypervisor and not inside the guest, you're not prone to getting compromised by the thing which is trying to compromise the guest. So you've got that isolation, coupled with high contextual awareness. And that was a pretty good kind of PowerPoint idea 18 months ago. And then he just showed a demo of it on Monday of showing all the kinds of attacks that could now get stopped. Attacks that would totally get through microsegmentation because they didn't jump from one network to the next. They jumped from one application component to another using the application itself. And so you really needed to see what was going on inside the application to be able to catch those breaches. Right. And so I think that's kind of where the sort of the next step is. I think much as I love microsegmentation, we must be under no illusion that it's a panacea.
I think what do you think, Ethan? We've been talking about this for a long time now.
Yeah, but it's not a panacea, is it? As Bruce was getting to.
Is it perhaps a magic bullet, a silver bullet?
Fairies coming down from heaven.
No,
it's not the angel.
We've established it reduces the attack surface. It gets us to a point where it's much harder to execute an attack, but it doesn't fix the endpoint security problem. You can still compromise that host. Ultimately, you still get an inroad there.
And you've got ways to migrate from one system to another without, with it completely undetectable to any.
It's just much smaller now.
And I think the point of my question, we'll talk about endpoint security in a minute, Simon, but the point of my question is, now that we've got this rich metadata, I'm not sure that security people are actually used to having so many levers to pull or so many policies to interpret.
So actually, just a point on that. So let's just make this statement because it's absolutely true. Detect to protect will fail.
Yes.
Okay, that's absolutely certain, it's called Turing, go look it up.
Which basically is an agreement of breach presumption that we can assume that
Yes.
we're going to get breached.
And so then what microsegmentation does is it reduces the attack surface and the vulnerability of the organization so that if an app gets taken out by a bad guy, then you have a smaller attack surface. It also gives you this amazing opportunity. So VMware back in 2008 spoke about introspection. Okay, Goldilocks is kind of, it's actually finally coming true. Why? One app per VM, only one thing to look for. We know how that app should behave. So if it does something weird, that's a breach.
You can quarantine it as well.
So the detect notion here is not trying to detect to protect. It's like something went wrong. Now we can respond, okay?
Yep.
And that gives you a smaller attack surface and an ability to automatically respond. Why automatically respond? Well, VMs are ephemeral. You can just chuck the thing away and start a new one, right? Okay.
I think that's the most positive I've ever heard you sound about VMware.
That's Bromium.
Oh, my mistake, sorry.
How did you not detect that he was talking about his own company? So endpoints, right? So Bromium, Simon, which is your company, is all about endpoints. The fundamental point is that we're seeing this rise of MDM. I alluded to it earlier. Mobile device management, managing smartphones, managing PCs, or pretending to manage Windows especially. Is it actually, we're seeing the rise of thin clients, tools like AirWatch and Citrix and, VMware's AirWatch and Citrix. They're all doing stuff to actually make it so that the endpoint is secure, so there's less happening on the endpoint. Is it possible to secure the endpoint at all?
No, it's not. Okay, let's just, for the same reason, right? Yeah. It's not possible to secure it. And the idea of, say, a VDI desktop is a good step along the path. It unfortunately presumes that by putting my VDI VMs inside the perimeter, that they are more protected. Well, I've just told you that that ain't so, because the network mailboxes are going to fail.
They still browse Daily Mail on the internet and look at crashy websites.
Yeah, and there are other problems too. In fact, if you look at all the profile managers, a lot of malware hides in the user profile. So you can create me a new magic VM every time I log on. I get owned. The malware hides in the profile. You throw away the VM. The next time I log in, it comes back.
It's in the
By the
profile,
way, if you deliver the profile anywhere else, it goes there too. Okay, because malware is smart, right?
Yeah.
So ultimately, that's a step along the path, but it's a good step. One of the things I advise customers to do in any VDI setup is always distrust those things. Just put VMs outside. Make them jump through some big hurdle to get access to anything. Because you should never trust an end user endpoint. You just shouldn't.
So one of the things that's not being talked about in networking today is the campus. So we're seeing the shift to wireless. We're seeing the shift to 3G, 4G, and now in the pipeline 5G. 5G is very exciting from my point of view. Totally separate topic, but 5G is going to increase the number of devices in the network. We're going to see IoT coming in. We're going to have campus networks flooded by IoT devices. Can we software define the campus? What does that look like if we do?
Yeah, so I've never had a really good vision of what this would look like, but I actually think that securing the mobile devices seems to be sort of the one hook that we have for that sort of environment. So a couple of years ago, I accidentally picked up a slide from marketing and started using it, and it had a thing about how NSX was going to secure IoT devices. And first of all, I said, please take that off because I have no idea what that means. But then subsequently,
most marketing decks, I have no idea what it means.
But I realized that the approach that we're using for securing, say, mobile handsets is conceptually applicable to IoT. It's just, the details of implementation would be a little bit different. But the idea that you can, on a mobile device, you can, very precisely define under what circumstances which particular app on that mobile device gets access to which particular set of resources within the enterprise broadly, effectively taking microsegments defined as we normally do, but extending those all the way out to a specific application on a specific device.
Yep.
And so I think that to me, that seems to be the architecture that makes sense. Is you assume that your endpoints are going to be compromised, but you do everything you can to limit how badly things can go wrong when that happens.
So let me disagree slightly. Okay, so it's good to put to microsegmentation reduces the attack surface for things you want to protect. But ultimately, if that same runtime is accessing stuff which is untrustworthy, you're in trouble. Okay? Because that's where the attacker comes from. So the average enterprise gets owned by a user browsing to some website, and that's where the attack comes.
Okay,
and
so
then
let's take this to extreme. There's a technology out there called NB-IoT, which Huawei's championing, which is a 5G technology, and it's about building a computer the size of a coin that runs for 10 years on a battery. right? So it's literally a battery-sized computer, and it will run for 10 years using a very, obviously a very small type of operating system. How are you going to be able to apply security policy to that?
So in general, let's just assume that any operating system is ownable. Okay. So in my view, the right construct is hardware-enforced least privilege within the OS. Okay. And this is where virtualization, my journey on virtualization says, okay, start with VDI, but now every single task within the OS, so every single tab in my browser, every single document I open, and so on, is going in a separate VM, at least as far as the CPU is concerned. The user doesn't see any difference. Okay. Then I can hardware enforce that least privilege boundary within the runtime. And I don't care if one of them gets owned. I just throw it away. So if I'm in the heart of your data center, I browse to Facebook and I get owned, it's like that tab of my browser is in the DMZ. So the key thing is that the attack, where the attacker comes from, which is the untrusted world, must be isolated outside.
Yeah.
Okay, it must have no way to pivot and go
But then
deeper.
you're saying then you've got to build a perimeter to create that.
No,
When you go back to
micro-virtualization,
firewalls.
so, well, at least in my world, every tab in my browser is effectively in the DMZ.
Yeah.
It
Okay.
has no ability to communicate with anything
But I'm
on
talking
my
about an
internet.
IoT device that's the size of a coin that costs $2. And I've now got them in
So
my
I think
factory, and
that-
I've got,
yeah.
we're talking now about IoT, which is 200 of them per square meter.
Simple assumption about IoT. Let's say that everything in the future with IoT will be better than where we're at right now. Okay, where we are right now.
That's hysterical.
It's
It's going to go
SCADA.
through the crap phase before it gets better.
No,
It's
we
going to
will-
get much worse. Look at what we've got today. Every single IoT device that's been made is
They're terrible.
ownable, right?
Yeah,
They're awful.
the SCADA devices are atrocious. So the only thing you can do with any IoT application
Yep.
is assume that the thing that's coming at you from the IoT device is trying to own you.
Is dead. All right, Bruce, what do you think? Can we do something in the campus? Can we segment it? Can we apply micro policy in some way?
Yeah, I mean, I think I'm in the same boat with Simon here. I think you work on the assumption that everything is going to get owned, and therefore you put it in a very tightly constrained, well-defined microsegment where it gets access to exactly what it needs to do its
Right.
job. That's the least privilege idea. And so the technical details of how you do that, I think, it's hard to figure out. Are we going to micro-virtualize a little tiny coin-sized device? Probably
Okay,
not.
but we've got a massive problem. Visibility. Effectively in networking, we have no visibility into our networks. We don't even know what our architectures look like. Your average networking engineer, as Nick said yesterday, is the state engine for an entire network. If this traffic starts happening across our network, we're not going to know. You're going to need a renaissance of, a veritable industrial revolution in networking telemetry to get visibility even into what's on the network, much less what applications are flying
Correct.
across it.
And one of the issues that didn't get mentioned yesterday is who gets to ask. Okay, so there's this presumption that I have the right to find out what's on the network. Well, every single networking vendor in the room here got owned by, somebody in the
Yep.
last year or so. Okay.
Cisco's got this massive problem with the NSA. They drove a truck through the gaps. Juniper had their problems with the.
Okay, and so the problem there is that if you presume the right to inspect and to find out, just to do sensible traffic management across a whole bunch of switches, who has the right to do that? Do you have the right to program this device? All of these problems suddenly pop up.
My problem is who's going to pay for it, right? Networking budgets have never paid for visibility tools or monitoring tools of any sort, right? And you really need to be in a situation where 25% of your IoT budget, of your networking budget, needs to be allocated to building monitoring, capture, analysis, data lakes, machine learning, repositories, that sort of stuff. That's a massive transition that hasn't happened yet, and I'm not even seeing a fart in a wetsuit about that.
So I wouldn't agree that the budgets have never paid for it. The budgets have always paid for it, but then we spend $100,000, $200,000, however much on our monitoring infrastructure.
Right.
And it's a terrible piece of software that we hate and we don't want to use, and people get burned, and so that tends to be the first thing to go with the next budget cycle. We've tried and failed. We got to do better.
So I will say that I think one of the reasons why network virtualization is as successful as it is because it does give you a level of visibility that we've never had before. The fact that every single packet is passing through a software vSwitch gives you a whole lot of ability to apply visibility, and then there's a pretty substantial tool ecosystem getting built around consuming that information. So I think there is actually a sign of hope there.
Thanks very much for listening to us today. I'm Greg Farro, and this is Ethan Banks. We're from the Packet Pushers podcast. Please give some thanks to Simon Crosby, he's from Bromium, and Bruce Davie from NSX of VMware. And thank you very much for joining us today. And always remember that too much technology would never be enough.